All right, today we're going deep into a world you probably never even think about, but that is changing, well, everything. We're talking about high-tech coatings, a science that is reshaping our reality literally from the atom up.
So let me ask you something. When I say the word coating, what's the first image that pops into your head? Seriously, what do you picture?
For most of us, I'm guessing it's this, right? A can of paint. You know, a basic layer of color, maybe some simple protection, and yeah, it's useful, but it is just the very, very beginning of the story.
Because the truth is, the coatings that matter most, the ones that are really shaping our modern world, you will never, ever see them. They are these microscopic shields, these incredible functional surfaces that are quietly performing miracles all around us every single day.
So let's get into it. First, we're going to look at the invisible shields that protect our world from falling apart. Then we'll explore surfaces that have been given some truly wild superpowers. After that, we'll see how these coatings can actually work with and even heal the human body. And finally, we'll look at why the future is, quite literally, coated.
So, first up, these invisible shields. Think of these as advanced coatings that have one job and one job only: to stand between our most important materials and all the forces in the world that are trying to destroy them.
And don't just think of them as a thin layer of something. No. This is more like a meticulously designed suit of molecular armor. We're talking about everything from massive industrial steel parts to the super lightweight alloys they use in aerospace. These coatings are protecting them from constant attack.
So just how effective is this molecular armor, really? Well, researchers wanted to find out. They took a standard high-speed tool steel and applied this ridiculously thin specialized coating. And the question was simple. How much tougher can this tiny layer actually make it?
The result? It's kind of mind-blowing. The answer was a reduction in wear and tear of more than 90%. And let's be super clear here, that's not a 90% improvement. It's a greater than 90% reduction in the physical wear on the material. You know what that means? It means critical parts can last 10 times longer. It's a total game changer for efficiency, for saving materials, and for saving money. And it's not just about friction and wear. Look at the fight against another huge enemy, corrosion. This chart from a study by Liu and his colleagues is just fantastic. On normal uncoated steel, white rust starts to show up. But add a simple zinc tin coating, it's delayed by a full day. And then there's red rust, the really bad stuff, that's held off for an extra 240 hours. That is 10 extra days of life from a layer you can't even see.
And the protection goes even further, into fighting things like ice. Scientists are developing coatings with a property called ice phobicity. It's exactly what it sounds like, the ability to actively repel ice, to stop it from sticking to things like airplane wings or power lines, which, as you can imagine, is a massive deal in colder parts of the world.
Okay, so we've seen how coatings can protect, but what if they could do more? Let's move on to our next section where we're moving past just passive protection. We're talking about coatings that don't just shield a surface, they give it actual superpowers.
Just picture this for a second. Imagine a surface that water can't even get wet. A surface so repellent that a droplet of water acts like a tiny little superball, literally bouncing right off the moment it touches down. This isn't science fiction anymore. It's a real field of science called superhydrophobicity.
So, how does this work? Well, on any normal surface, a water droplet lands and spreads out. It clings to it. But on a superhydrophobic surface, the water beads up into an almost perfect sphere. And here's the magic trick. It's barely even touching the surface. It's actually riding on a microscopic cushion of air trapped underneath it. That means it can roll away with the slightest nudge, and it takes all the dirt and dust with it.
So how in the world do they pull this off? Well, it's this really clever two-part strategy, and it's often inspired by nature, like the surface of a lotus leaf. First, you engineer the surface to have this incredibly intricate, complex pattern of roughness at the nanoscale. And second, you apply a chemical finish that has very low surface energy. Those two things together make it almost impossible for water to get a grip.
And this is where the applications just get wild. I mean, we've got researchers using graphene oxide to make bamboo totally resistant to mold. Others are using polyurethane to strengthen priceless, fragile ancient paper without damaging it. We're even seeing these patterned films that can act as tiny, self-contained laboratories for chemical reactions. And of course, the big one, fabrics that completely clean themselves.
Which brings us to what might be the most incredible application of all. Coatings that can work with and even heal the human body. This is where surface science gets really, really personal.
So let's walk through the journey of a medical implant.
The big challenge is that our immune system is amazing at spotting and attacking anything that's not us. So when you put a titanium implant in, the body can freak out. But what if you could give that implant a disguise? Researchers use a coating of something called hydroxyapatite, which is a material that basically mimics our own bone. This coating acts like a diplomatic passport. It fools the body into not just accepting the implant, but actively bonding with it, which speeds up the whole healing process. It's incredible.
But hold on, it gets even better. These coatings aren't just passive diplomats. They can be active bodyguards. We can design them to fight one of the biggest dangers in any surgery: infection.
Check out this data from a study by Wang and his colleagues. It's just amazing. They made a coating with polydopamine and silver nanoparticles. When they put it on a titanium surface, it wiped out over 96% of E. coli and nearly 86% of S. aureus, a really common and dangerous staph bacteria. This isn't just a barrier, it's an active bacteria-killing surface.
So after all of that, where does this take us? What does the future actually look like when we can basically tell any surface to do almost anything we can imagine?
When you boil it all down, this whole field, from molecular armor to surfaces with superpowers to coatings that can heal us, it's all about one thing: mastering the control of matter at the tiniest scales imaginable.
And the reason we do that is actually very simple. We do it to solve our biggest, most complicated problems, things like energy efficiency, material shortages, human health, and protecting our environment.
Which really leaves us with one final thought. The next time you see a simple can of paint, I want you to remember this invisible world that it represents, and then ask yourself, what seemingly impossible problem are we going to solve next with nothing more than a simple coat?